Hello, it's Anthony here from Semi-Informatic, and today we're doing a first contact with Shenzhen IO. Shenzhen IO is a game from Zachtronics, who have also bought out games like Space Chem, TIS 100, Infiniminer and Infinifactory. So, let's get started then. So what this game is about is you're an engineer who's moved to China to take up an engineering job, because there are no more jobs in your country for engineers. It could quite possibly be Australia, where the only thing we seem to be doing is selling financial services to each other and digging rocks out of the ground to sell to other people. So, you get an email client in which you can read emails from your co-workers. And you get this message that tells you to read the manual. Now, the manual is a 40-page PDF that details the technical aspects of your job. This is a game about programming, so if you're not a programmer you might struggle to understand this game. You can possibly come at it from another direction and treat it as a puzzle game, and you just have to learn how the puzzle works. It is also assembly language programming, which is the most obtuse style of programming. Now, I'm not a programmer. I know how to program, but I'm not very good at it. So if you're screaming at me while watching this saying I've got some of these solutions wrong or not optimal, that's because I'm not a programmer. So let's have a look at our first job that we get. So we are building a mock security camera. It should have two blinking lights, one to blink in a regular pattern to show that it's on, and one to behave like an internet transmission light to show that it's transmitting data. And apparently somebody else was hired and has already had a go at this and they've failed. So let's open what they call the concept CAD, which is where we're going to design our camera. So we've got two interfaces, active and network. So this is going to be the active light and this is the network light. And this thing is a little embedded, chip that's going to do what we tell it to do. So active and network are simple outputs connected to LEDs or lights. Control the active and network outputs with fixed repeating signals as indicated in the verification tab. Let's go here. So we can see at certain points in the program they want us to send high or low signals. So we just run this now. We can see that the active one's already working pretty okay and the other one's not working at all. The poor engineer who had the job before us has said, why is this so hard? So if we just step through the output, we can see that it's going along, and then when it gets to here it jumps up and then jumps back down. So let's start again. So the first instruction, we move the value of 0 into P0. Now this is P0 here. So we move the value of 0 into this active LED, which will turn it off. So yep, we're off. Now when we get to the next line, we're sleeping for 6 cycles, and then we're going to move a value of 100 into P0, which will turn it on. And it does. And then we sleep for 6 more. So this is a fairly regular thing, 6 on, 6 off. I will resist making a Karate Kid joke. Now this one looks a little bit more complicated. It's still a pattern, but we may have to do some more lines of code. Now, when they said in the instructions an internet light, I immediately thought, oh, is there some kind of instruction or function that I can hook that can get the system time so I can seed a random number and make it blink on and off randomly? Apparently, that's too complicated for the first puzzle. I should have just looked at the waveform and said, yeah, I can just replicate this. So we drag our integrated circuit over here and we hook up P0. We can pretty much copy what we're going to do, what he's done up here, and just make some changes. So if we go move 0 to P0, now they sleep a little bit earlier, or they start a little bit earlier. So 1, 2, 3, 4, 5, 6, and this would be 1, 2, 3, 4. So if we sleep 4. Move my mouse out of the way so I can see what I'm doing. And then we move 100 to P0. And that looks like 2 cycles. So we SLP, I've made a mistake there. And then we move 0 into P0. Now, just so you know, I'm only going to solve the first 2 puzzles. This game is the puzzle, so I'm not going to go through any more than the first 2. And then it looks like we sleep for 1. And then we move 100 into P0. Have I got this right? Move 0 in, sleep for 4, move 100 in, sleep for 2, move 0 in. No, we'll find out when I run the bloody thing anyway. This seems longer than... Let's just see what it does. Alright, so it never pops back up for... Yeah, okay. Well, let's step through it. So they get my 100, and then we sleep for 2, and then they sleep for 1. Then I move 100 to P0, and then it immediately moves 0. Alright, so that's our problem. The problem is there's no break, but because it loops around, there's no break between this line and this line. So SLP1, and that should get us the next part. Yep. Actually, it actually actually does the whole thing for us. So you can see now there's no red lights. You can see our security cameras blinking away here. And this thing has to loop for 80 tests, although it does the last couple fast. So this screen is fairly typical of Zachtronics games, where you get to see how well you did and how well other people did. So I did this in 12 lines of code, and apparently, I don't know how they did this without cheating, some other people have done this in like 5 lines of code. So that's what I mean when I say I'm not a very good programmer. So that's great. So we return to our email, and then everyone congratulates us and says thanks very much. And we get some more emails from our staff. There's usually some pretty good stories with Zachtronics games. I quite fondly remember Space Chem's story, but they're usually pushed into the background. So this is our second puzzle, which is a replacement factory module. We're going to go to please enjoy a game, and it turns out that one of our co-workers, or this guy might be the guy who owns the business. We'll see if we can find him. Yeah, he's the chief staff engineer. He's our boss. So his daughter has programmed a solitaire game, and he wants us to play. So if we go back home, we've now got solitaire on our desktop. Now, I've never played a solitaire game quite like this. They seem to have these cards that don't have numbers on them that they're referred to as dragons, and this one as well. I don't quite know how to handle them yet. Now, we can't do similar colours in solitaire, can we? So yeah, this is about as far as I've got with this thing, and it is actually an objective to win a game, so I'll get to it eventually. And they do have instructions, but as usual, I have not paid attention to the instructions and just gone straight ahead. So let's get going with our next module. This will be the last one that I'll do. So they have some older equipment that requires control signals to be amplified. So there's no design on this one. We've just got control in and control out. So let's hook up P0 and P1. Control in is a simple input connected to factory equipment. Control out is a simple output connected to factory equipment. It should be boosted multiplied by 2. Okay, if you dig back through your manual, you'll see that there is a assembly language code which has you multiplying things. So I made a mistake the first time I did this. I'm going to make it on purpose again. So if we just go move P0 to the accumulator. Now the accumulator is a little piece of memory that you can store things in. And if we then go mul to accumulator, maybe it's just mul 2 actually. That automatically knows to use the accumulator for that. And then if we just go move the accumulator to P1. So what we're saying is whenever you get something coming in, move it to the accumulator, multiply it by 2, and then move it to P1. So in P0, multiply it out. So when you try to run this, it just goes nuts. And it took me a while to figure it out. But you need to have things sleep for a cycle to take place. And there's a big page in the manual that says make sure you get enough sleep, which explains this. And it wasn't until I printed it out and read it on the train on the way home that I realized, oh, I'm an idiot. If I had just read the manual, I would know what was going on. So, sleep for one. Sleep for one. Well, what we might do is we might put that at the end because I don't want to miss the first instruction. We sleep for one. We multiply move the P0 into the accumulator, multiply it by 2, move it to the P1, and then sleep. So let's see how we go. There we go. Couldn't be simpler, could it? Now, for those of you watching at home who are completely confused, don't feel bad. Assembly language programming is one of the most obtuse and difficult things that you could ever do. I have avoided doing it for many years. I mean, I've always wanted to, but I thought this is way too hard. Right, so we did okay. Somebody's done it with less power usage and with less lines of code, and I would really like to know how they did it. But unfortunately, this is how I did it. I will return to our email again, and our co-workers email us, and they send us our next thing. And that's how the game goes on, as you keep getting more puzzles to complete, or in this case, more things to design. But I will show you that now we've got access to a larger version of the integrated circuit with more inputs and outputs. I just can't figure out how to drag it out. There we go. A bridge, which I don't quite know what the bridge does. I think we can just write notes with this thing. And they occasionally will say, don't use this part. This is a special one of the initial circuit that only has X inputs instead of P inputs. P inputs are for just pulses, I guess, electricity, and X inputs are for actual data, so numbers and things like that. Now, what do we have to do on this one? Oh, right. So the idea on this one is that the button is going to be pushed, and when that pushes, you should make the inputs the output just oscillate up and down. Now, I'm not going to do it. You can figure out how to do it. That's Shenzhen IO, something that I've been really interested in. Zachtronics always they go to a fair amount of effort to sort of build a game world. Like if you download the manual and print this out, they've made up fake companies, so some of the parts you use will be built by other companies, and their data sheets will have like a short history of the company. And it's like there's a chip manufacturer in Denver who's like a husband and wife team, and it goes into detail about how they bought their first factory and things like that. And then there's just one part of the manual that just contains just weird stuff people have printed out off the internet, like some guy's GeoCities page and things like that. So it's a pretty interesting game to play. It's similar to TIS 100, which sort of has the same assembly language backing, but it's about you finding a machine that your deceased uncle was working on, and your aunt has said, can you get this working? It was on his desk when he passed away. Zachtronics games are pretty good if you're into this thing. It's nice to see something like this come out, because there's obviously a segment of the market who really like these sort of puzzles, but nobody's making them except for this one place, maybe one or two places. So yeah, that's Shenzhen IO. I think it's about $15 on Steam. If you think that you can get in and solve some of these things, by all means, go for it. I recommend it. See ya.